Hi guys, so the thought is that you would have already done the check your understanding on page 175 and the lesson 10-2 practice on 176 by yourself and or with your seatmates' input and help. Since you've already done the lesson, then this is your chance to apply what you know to some practice. So be sure you tried first and then use this to help check and or supplement anything you need to know besides what the key would tell you. All right, so let's see what we got here. All right, so first they ask us to solve the systems by any method. So I'm going to choose substitution because on this first system here, if I solve this one for y, hopefully you noticed you would have ended up with 1/5 x, which is fine, with a rise of 1 and a run of 5. But then I would have had -2/5 for y-intercept. And it's going to be hard for me to be accurate working with that. So I'm going to solve one of these for a variable. Maybe I'll just solve this one here. So if I minus y from each side, I'll get x equals -y plus 8. So that's what x equals. So I'm going to put that in right here on the other one for x. So I would have -y plus 8, replacing x there, and then I would have minus 5y equals 2. So that would give me -6y equals -6, and so y equals 1. And so make sure I put that in the y position. Then if I plug that in here, -1 plus 8 is going to give me 7 for x. So the solution to number 13 is 7, 1. And I chose, it says explain why you chose the method you did. I chose substitution because graphing would have had me graphing a y-intercept of -2/5 that I thought that was tricky. So on 14, I'm going to do substitution again because I already know that x equals 2y. So I'll just have 2y minus 7y equals 10. So that gives me -5y equals 10. So y is going to be -2, and x is 2 times y. So that's going to be -4. So -4, -2 is the solution to the second system. And then 15 says Theo buys a slice of pizza and a bottle of water for $3. So pizza plus water was $3. And Ralph buys 3 slices of pizza and 2 bottles of water for $8. Now this one wouldn't be too bad to graph. You could do it by graphing. I don't have a piece of graph paper handy right here, so I'm going to do substitution again. So if p equals -w plus 3, just because I minus this w from both sides, then I would have 3 times -w plus 3 plus 2w equals 8. So -3w plus 9 plus 2w equals 8. So -w equals -1 if I combine these like terms here, and then minus 9 from both sides. So w equals 1. So water is $1, and pizza must be, since he bought a pizza and a water for $3, pizza must be $2. So I could plug it right back in here also. -1 plus 3 would be 2. All right, Delano was asked to solve the system, and he made the tables shown below. So he plugged in some x values to this function and got these y values, and he did the same for this function. Are any of the ordered pairs in the tables solutions of the system? Well, we have the same input, 0, 1, 2, 3, 4, 5 on both, but we don't have any matching output. So nothing on these tables is a solution to the system. No, none of the ordered pairs make both equations true or match on both tables. Something like that. There's no ordered pair that matches on both on the tables for both equations. So what can we conclude about the solution of the system? Well, assuming it has one, first of all, so assuming there is one, which there would be, because if you look at these graphs, this is a line with a slope of 2, and this is a line with a slope of -1. Lines with different slopes are going to cross, so there is a solution to the system. And I noticed that from 0 to up to 3, all of these, that this function on the right, the outputs of this function are all higher. And then once you passed 3, so for 4 and 5, these inputs were lower. So the lines must have crossed somewhere between the input of 3 and 4. So the solution must be when x is between 3 and 4, because the inputs are higher, no, outputs, sorry, the outputs are higher on the second function up to 3, up to x equals 3, than lower at x equals 4. So the other line must have crossed it and become higher at that point. Would you choose to solve the system graphically or algebraically? Well, I would choose algebraically. It's going to help me be more accurate because if those cross between 3 and 4, they don't cross at a whole number, so finding a non-whole solution on a graph is tricky. You can find it algebraically easy enough, you get a fraction, but on a graph you'll see that it crosses in a non-exact place, but you might be guessing as to exactly what the points were, the coordinates of the point was. Alright, so a rock climbing gym called Rock and Roll charges $2.75 to rent shoes and $3 an hour to climb. A competing gym, Climb the Walls, charges $4.25 to rent shoes and $2 per hour to climb. So we're going to write an equation that gives the cost y of renting shoes and climbing for X hours at Rock and Roll. So let's say it's $3 per hour plus $2.75 for shoes. And for Climb the Walls, it's $2.50 per hour, X, plus $4.25 for shoes. All right, now we're going to solve the system using any method. And I'm going to choose substitution because these cross the y-axis at 2.75, 4.25, and then when I start going up 3 and over 1, it gets too messy for me. So that's my justification for why I'm choosing substitution, because the y-intercepts are on non-whole numbers, so that makes them tricky. So if this stuff equals y, then I'll just put it in right here for y. So I would have 3x plus 2.75 equals 2.5x plus 4.25. And then I'll minus 2.5x from both sides. So I'll get 0.5x, and then I'll minus 2.75. Oops, 2.75 from both sides. And I'll get 1.5, and then when I divide, I'll get x equals 3. And so if I plug it back in here, I will get 9. 3 times 3 is 9, plus 275 is 1175. What does the solution to the system represent in the context of the problem? Man, I hope you spend some time thinking about this. This is an excellent question. Well, if it's a solution to the system, it makes both of the equations true. So what we found is the amount of hours and the cost that would be the same at both rock climbing places. So it means that for 3 hours, both gyms, let's say, because they're called a rock climbing gym, both gyms will cost $11.75. So that is the same solution for both of those. So 3 hours, $11.75. All right, so then for the last question, suppose you plan to rent shoes and go rock climbing for 4 hours. Which gym offers a better deal in this case? So you could plug 4 hours into both of your equations right there. Plug it into that x and to that x and find out what the cost of each gym would be. Or a little higher level of thinking might have told you that for 3 hours, or at 3 hours, the gyms are equal. And then if you look at the slopes of these lines, the first one's higher. The first one is $3 per hour, and the other one's only $2.50 per hour. So climb the walls. Walls is less per hour, so it will be a better deal for anything more than the 3 hours where they match. So you would pick climb the walls. It would be cheaper by 50 cents for that extra hour. All right, so we're going to write a system of equations. Now, it's important to note that we always are using y equals mx plus b a lot here for our graphing. And then when we have to write an equation, we can't just assume that we have a y-intercept. In order to have a y-intercept, the value of x has to be 0, and it isn't anywhere. So we'd have to figure out, if x was 0, what would y be? And it looks like every time x goes up by 1 here, this is going up by 2. So every time, if it went up 1, this would be 2. So now we have a y-intercept. And the change in y over change in x is going up, y is going up 2 when x is going up 1. So the slope is 2, and we found out the y-intercept is 2. So y equals 2x plus 2. Then this one, let's see, this is going up by 2, and this is going up by 1. So 2 and 1. So change in y over change in x. Y is changing by 1 when x is changing by 2. So if I went, when x changes by 2, I would get to 0, would be in between these two. So we have to, that would make this be 2. So the y-intercept is 2. So y equals 1/2 x plus 2. So they both had y-intercepts of 2. So that's the first thing you had to figure out. Then we can solve them using any method we want. Now these wouldn't be too bad to graph if you feel like it. I'm just going to do substitution. So I'm going to put this in right there for y. Since it's equal to y, since this and y are equal, I can make a substitution for y. So that would give me 2x plus 2 equals 1/2 x plus 2. And if I wanted to clear my fractions, just this wouldn't be too bad of a fraction to deal with, but I can multiply everything by 2 so I don't even have to. 4x plus 4 equals x plus 4. So then if I minus x and minus 4 to both sides, I would get 3x equals 0, so x equals 0. And we already knew this, actually. By the time we wrote the equations, we should have known what the solution was. Do you see these guys have the same y-intercept? That's the point where they're going to cross. So they're going to cross at 0, and we already know that y is going to be 2, but let's plug it in anyway. So if we would have y equals 2 times 0 plus 2, so y would equal 2. So if they're two different lines, right, two different slopes, but they have the same y-intercept, then those lines are crossing at that y-intercept. So that's the solution right there. That's on both tables. Didn't really need to use any method except observation. All right, so it's kind of weird to have you do the entire lesson. I mean, it's not like I wasn't explaining it to you, but I didn't actually get FaceTime with you. So please, if you have any questions or anything you want to talk about, just make sure you put a sticky note on it and highlight it and remind yourself that you want to talk to me about it, and we'll talk about it. And then go ahead and start now the next lesson. So watch the mix for 10.3 now, so you have less to do later. All right, I'll see you soon.